So hello, everyone. My name is Dan Petrov, or my full name, Daniels Petrovs. I am a backend developer at Platogo. And today I have the honor to tell you about connecting Ruby and Elixir microservices in a high-load gaming platform with some very interesting details. And of course, we will also talk about gRPC and its current state in the Ruby and Elixir ecosystems. Without further ado, let's start. I noticed that one of the meeting rooms is called Sound of Music. That's a nice reference to Austria there. You'll see why. So a little bit about me. I'm currently mostly a backend developer with some full stack experience. I've worked on different kinds of microservices, mostly Erlang and Elixir, and more recently Ruby as well. I usually do Elixir development mostly, and nowadays in my free time and sometimes even at work, I also do development in Go. And also I contribute to open source projects on GitHub and start a bunch of new ones, either personally in my own time or at work. That avatar you see, this is something that everyone at my company gets when they join. So it's kind of immutable, and they're supposed to represent us as unique characters. It's really nice touch. And about my background, originally I started in QA in a live casino company. So what is live casino? In a nutshell, it is casino games that are live streamed to people over the internet, and they can play them on different devices, usually through a web browser or native applications. And it usually involves real money gambling. And a bit about the company I'm at currently, Platogo. We are a pretty small company based in Vienna, Austria. That's in Europe, so no kangaroos there, unfortunately. And we have been acquired by this other bigger company called ScreenTube a few years ago, and which is owned by this other larger company called Novomatic. They're a very big player in the gambling market. We are mostly focused on social gaming. What is that? It is essentially implementing all of the social features that surround games and platforms which have a lot of users. So, for example, XP systems or loyalty system mechanics or VIP systems, missions, leaderboards, league divisions, that sort of thing. And our company is still quite independent. We have less than 25 people, split into 3 teams. I'm from the backend, or we call it the server team. And we maintain many multiple services in Elixir, Golang, and also one big Ruby monolith. Those are our core parts. And of course, our main revenue drivers are our apps. Currently, they are South Park and Gaminator. They occupy the top spots in the German and Hungarian Play Store and App Store markets currently, with millions of downloads. I won't tell you the exact numbers, but you can always look it up if they show it. So a little bit of context, what it looks like. This is our lobby. To make it very clear, we don't usually make the games themselves. We get them from suppliers. For example, our parent company is one of them. We provide everything around it. So the lobby, how the profile system works, how the users can interact with one another, how they can build their own teams and complete missions and earn in-game currency and experience from this. So all of this is using virtual currency that is just for fun. So this is the most popular game that our players play, Book of Ra. You might have heard about it at some point. And the most important mechanic in our platform is spins and bets. So when people want to play a game, they have a certain balance. You can see it down there in the bottom left in their account. And this determines, how much they can actually bet. If they don't have enough money, then they cannot place a bet on a certain game, obviously. And when they perform a spin, they stake this bet. So they either win or lose. This is a very simple version without any of the other mechanics like bonuses, boosters, etc. Just the spins. So a spin is kind of like making a roll in a loot box in any other popular video game. But in our games, players do this very, very frequently. So many, many times a minute, because they obviously want to do a lot of spins and play a lot of games this way, just like in a real casino, for example. So some very basic statistics. We have usually around 25,000 concurrent users, like on an average day during the daytime. Lunchtime is usually the best time from what we've noticed for obvious reasons. People have some free time to spare when they can play a few games. And we usually see about 7,000 spins per second. That's our most important event and our most frequent one, of course. So a little bit about our platform. Like I said, we have this one Ruby monolith, which is the oldest and most important part of our system. It has over 1 million lines of code. And around that, we have a bunch of Elixir microservices. These are the newer ones, and almost all new services that we develop are in Elixir. We have a few small Go microservices, usually for data processing and things like that, or some very small supporting things. And this is all running now on Kubernetes, on EKS. We have Traffic and Linkerd for our service mesh. This is a pretty new thing. It didn't exist, I think, 2 years back. So we're still getting used to it, but so far we're quite happy with the setup. You'll see why we have Linkerd in a minute. And we have multiple CDNs, multiple databases, and we have Kafka and RabbitMQ as our data brokers. A very, very large platform. So why we started moving Wallet out? So what is this wallet? Like I mentioned before, every player, they have some kind of balance, like in any game that has virtual currency in it. And making sure that you keep track of the right balance at all times is obviously very important in any game centered around currency. And we noticed that this logic was a bit too much for our large Ruby monolith. And since we integrate with our parent company and we want to integrate with future partners as well, we needed some more advanced features of Elixir for this. And this is where we realized we needed to move this out into a completely separate service. And also at the time, I wasn't there at the company yet, but at the time, gRPC was starting to gain some traction. and also libraries for working with it for Ruby and Elixir were there, and they were also fast enough in benchmarks for our kinds of loads. And also we introduced Linkerd, which has this really amazing feature of gRPC load balancing almost out of the box, and also a support for tracing. And so that is kind of a very important feature, especially when you're running on Kubernetes and you have multiple nodes for your app and you want to do load balancing. So how did we do this? So the first thing is obviously to set up the repositories and figure out how the services are actually going to talk to one another. And in our use case, our monolith would be the client or the stub in gRPC terminology, and our wallet service would be the actual gRPC server. And for our use case, just unary gRPC is completely sufficient. And we decided to write all of our protobuf definitions in the wallet repository, and then our monolith can just read them and create the necessary Ruby classes from there. But you can also just keep a dedicated repository for your protobuf definitions. That's a technical detail, whatever works best for you. So on the Ruby side, it was quite smooth, especially since Ruby is officially supported, since it's quite a mainstream language compared to Elixir. So here we have one of the most common examples of what we need to do is get a balance of a player's wallet by its ID. You just make some sort of convenience method around it, and we just call our generated stub with our defined methods get wallet balance. We create this new balance request and we execute it, and then we read the balance from the response. So very typical stuff. And you can be very nice and make a convenient rake task. We made one called generate gRPC, and under the hood, it just calls proto-C and cleans up some things and makes sure that we can very nicely generate the Ruby classes whenever we update our protocol buffer definitions. And on the Elixir side, it wasn't that great originally. So before 2022, the main Elixir gRPC project was kind of abandoned for about 2 years, and we had our own fork of it where we had to do some small patches. The rest of the community also had their own forks with their own patches, but thankfully in 2022, it got its first release in almost 2 years, which is great. And now there is very active development going on in the projects again. And if you look at the list of supported features, pretty much almost everything is there except for gRPC reflection. But that's mostly a nice to have. It's not that critical. And they seem to be already working on it. And also this week I noticed that Jose Valim, the creator of Elixir, has some interest in the project, and he made some small contributions there as well. In terms of working with proto-C, Off-Grid Electric actually made a really nice library that adds a mix task. The mix is the build tool for Elixir, where you just define your configuration, how you're going to generate your Elixir modules, and it does almost everything for you. So in the context of Elixir, you don't generate classes. It's not an object-oriented programming language. It's functional. So all of the code in Elixir has to exist in Elixir modules, and modules can be in Elixir files. So that's what you generate. So here we have a small example where we can get a balance of a specific wallet. This I stole from another project that I'm going to show you in a few minutes. So it's very, very similar almost to the Ruby code, since their syntax is quite familiar, let's say. It's still slower than the Go implementation, but it's still fast enough for us from the benchmarks. So no big issue there. We don't have to switch to Go just yet. So how does this all look on a very high level? This is omitting a lot of the small details of our platform. The most important thing is the Platogo application server. This is our most important Ruby monolith. This is what our client apps talk to the most. And usually it's over HTTP. And for example, we want to start a new game. So the most important thing that we need to do is get the player's balance, obviously, so they know how much money they have to work with. And we also want to start a game session. I should have maybe mentioned that in our wallet umbrella, we have the dedicated wallet service, and we also have another microservice called the Game Session Manager, because managing the balance and also managing these game sessions go hand in hand. So it made sense to keep them in one umbrella, as they share a lot of functionality using an intermediary shared app. It's a very common pattern in Elixir monorepos, let's say. So here, our Platogo application server, PES, it can call get wallet balance and get specific player's balance quite quickly, and also start a game session. This is what it looks like on the more platform side. So there's our Kubernetes cluster. We have our traffic incoming and going through traffic. That goes to PES, and then we have load balance requests to multiple parts of our GSM service and our wallet service. And that under the hood talks to our dedicated wallet database. So that is a very, very high level view of how it looks like. So in this case, gRPC was a really great solution for us. Maybe I should mention why we are using gRPC in this case and why it's not that common in Elixir, but I'll leave that for later if we have time. So a little bonus thing is that with gRPC, you can also make other client applications that call your gRPC servers. So one thing that was very useful for us is making our own game launcher. So this is something that we made to let us develop without waiting for the client team to implement a finished client. So this under the hood uses gRPC channels. And we implemented this using Elixir and Phoenix Live View. It's this really awesome framework for making web apps without needing to write almost any JavaScript, with real-time updates on the UI. And this is how it works under the hood. So without going into too much detail, to launch certain games with our partners, we need some information from GSM, the Game Session Manager service, and we also need to make HTTP calls to our partner service to actually launch the games with special parameters. And to get those, we need to make some calls to GSM. Luckily, with Elixir, this was quite easy. We used the same owned mix compile task that I showed you earlier. We use the same exact protobuf definitions. We generate a stub client, but this time it's in Elixir instead of Ruby. And we can wrap that into a Gen server and keep reusing the same gRPC channel. If you're not familiar with what is a Gen server, maybe if you've worked with Akka, you've heard about this. It's basically a stateful actor that you can create, and it runs in its own Erlang virtual machine process. You can send messages and get things back. So with all of this put together, we made this really nice launcher in about 3 days. So you just run it, and it makes gRPC calls for you under the hood, and you have a full-blown web app in the browser. So that was very helpful for us because it saved us weeks of time before the client team was done with an end-to-end working client with the new partner APIs. So what are the results? We started migrating all of our active users from the internal Ruby wallet implementation to the new wallet service this year. And now I'm happy to say that pretty much all of them are migrated. So we can always keep track of how many active wallets we have at any point of time. We didn't experience any gRPC-related bottlenecks so far. The only issues we had were with wallet itself, but it didn't have anything to do with gRPC or the Elixir implementation or the Ruby implementation at all. And it was also quite understandable for new developers. It was very easy to onboard them into the protobuf format and how to work with a proto-C compiler and how to update the definitions when we needed to create new requests and responses, for example. And what will we do in the future? In the future, we are already looking at using gRPC more to let other Elixir services talk to PES directly, because very far down the data processing chain, it's not that great, and it's not as responsive as like a direct communication between our Ruby monolith and the wallet service as we'd like. We were also thinking maybe we could use it on the very end user client side. I know that it's possible, but that still needs some more research. And of course, we are thinking of making more debugging tools. One idea I had is to make maybe a nice Go CLI for working with the wallet service directly and not having to go through Elixir or through the Ruby monolith at all. This would be really great for debugging. And one last thing I forgot to mention, why gRPC is not usually the first choice when people have purely Erlang or Elixir-based clusters is because distributed Erlang, the way that Elixir nodes can communicate with one another, they already have support for remote procedure calls out of the box. It's already there, so there usually isn't a reason for using, yet a dedicated protocol, which is also based on TCP. So, but when you have a mixed stack, when you can't really just throw your entire legacy app in Ruby or Java or any other language away, and you want to integrate new services in a completely different stack on a completely different virtual machine, then gRPC is a really great option, in my opinion. Because as you've seen, it works even across paradigm boundaries. So Ruby is object-oriented, Elixir is almost purely functional, and it still works quite well together and is easy to wrap your head around. So that's it for me. And in Austria, we say Danke schön. I'll leave some links for you here in the end. You can always check me out on Twitter or GitHub or on my website. You can check our website. It'll be updated very soon, I promise. And of course, some links to the projects that I mentioned. So that's about it for me. Thank you for listening.